Hello everyone, this is a follow-up video following Prismatica Dev's Parallax Occlusion Mapping video. So I made a comment that states this. If you use TAA or TSR, you can annihilate the stepping effect with a dither. You'll be able to keep your max steps to extremely low values while still looking good. It's way better if you use a blue noise dither too instead of the stock one. The steps can be optimized on distance too from the camera. Been suffering a lot in making this work since we're using Parallax Occlusion mapping on our landscape. Lot of optimizations and little tricks, especially in blending the different layers. If you use pixel depth offset, I suggest turning off contact shadows too. Those are the ones that most of the time make you look all glitchy and stuff. So following that, we're gonna dig right in. I'll be posting all the resources and Prismatica's video too down in the description. So we'll start by making a new level. A basic one is fine. We can delete the floor. We can add a landscape, since we're gonna test this on a landscape. But it will work on a normal actor too. Doesn't matter. And now we can save the level. Perfect. Now we need 3 material functions. We can copy and paste those. So the first one is a utility function for the UVs, which is material function UVs. So these are the 3 material functions over here. I'll be, of course, posting this in the description as I stated. All you need to do is select them all the nodes in here, delete this output result, and just paste. All this does, it's just a switch between landscape coordinates and texture coordinates. Landscape coordinates is better fitted for landscapes. It avoids some stretching, other weird pixel like glitches, especially on like very stretchy triangles. Global tiling, just global tiling. Nothing much to explain there. And it has an input for relative tiling to the global, so you can adjust per layer if needed. Right, we're done with this, so we can save and close. And now we can create the dither material function underscore blue noise dither temporal AA. As before, we can copy from here and paste it inside. The only difference over here is that now the effect is based on time and the scale is different from a normal dither. Normal dither has 64, 64. You'll see the effect in play when I'll show the difference between the two. And now the main function. MF POM simplified. I'll explain why simplified after. As before, select everything and paste. So I'll go step by step and just give a brief summary of what's happening here. So it's the warp position offset. We offset up on the normal warp position offset. This is useful especially if you want to match the terrain to the player, because parallax occlusion mapping can actually push the terrain downwards or upwards. And is an offset for the shadow, something that needs to be done so it doesn't self-shadow itself. This is the channel for the height map. Here we need to assign the UVs. It's just a reference plane, just a parameter. just the height for the parallax occlusion mapping. This shadow penumbra that's using the shadow. This is the max steps. So here we need the blue dither. Connect it like this. This is just a smartish way to handle lower samples while still looking good. Basically, I have half the samples, then multiply them by the noise and regain some detail, just add it together. It's just some mathematics over there. And here you make sure that your steps are never zero, because that's not a valid step. So you always at least want to have one step. You'll see the effect of this after. Here, you know, the blue noise dither too. Just connect the random into here. This is just something similar to this, just different way. The light vector is to calculate the shadows for the shadow penumbra and everything. Same with the vertex here. And so I use this to retrieve some specular information too. This divide here is how strong you want your specular to look. I didn't expose it because I'm fine with a 8. You can always expand and expose anything you need from this function. Here's the calculation for the shadow map. Here's an optimization. This is basically what I was talking about, that you can mask based on your distance. Because you actually run fewer, basically won't run the instructions after a certain range. It will be just a normal texture. I'll show you with a debug texture after. And this is like my work in progress stuff that I haven't really looked at it in a while. It's really work in progress. It's not really ready to be used, but it's in here. I'll show you what it does exactly after. And after all that, we just output everything. That's all. So now we're gonna create the material for the landscape. It actually uses parallax occlusion mapping. So I'll create a new material landscape. I already create a new instance for it. Let's create a material instance, rename it like that. It's gonna save them. So the first step is that I always like to use material attributes. So I just check material attributes. Then we need some textures. My favorite texture to use are two textures from Megascans, Mossy Rock and Riverbank. I'll be leaving their IDs in the description. If you don't know how that works, by searching with IDs, you open Quixel Bridge, and in the search bar, you can search the ID, and it will show you the asset. Well, if you want to add it to the project, just download and add. I always do high quality, so it's basically 4K. So now we can start with just the mossy texture as an example of how the parallax occlusion mapping works. I usually make all the textures shared wrap. There's some exceptions regarding UVs, for example, Pivot Painter, but shared wrap shares the samplers and is more performant, especially on AMD from what I heard. You can make the material attributes, connect the base color, the normal, and in case you didn't know, ORDP is the standard of Quixel. O is ambient occlusion, R is roughness, dP is displacement. In order, so ambient occlusion, roughness. Can connect here, and we have our very basic material that we can apply to the landscape. So now we can see it is just a normal texture with no depth to it. So we want to add the parallax occlusion mapping to these textures. So we can use the POM function. And this is why I called it simplified. You can see it right here. It has just 2 inputs. This is because in our project, we know that we're always going to use quixel textures for the landscape. So there was no point for us to expose a lot of the settings. And we had RD tools, which we could extract displacement maps and adjust them from in editor without any adjustments from in here. As you can see, the channel for displacement is red. You can also make an input pin to expose this, but for now we need it on the blue channel since Quixel uses blue for displacement. Something I forgot to show you is this expose to library. If you can't find your function while searching it, you can go in it and click this checkbox, and the category is going to be into. So we can do that for all our material functions and make sure to save them. So now we will need the UVs, but as you can see, it's using already the material function as its default. We'll only use the UVs here if you want this layer to have a different scale compared to the global scale. But now we need a height map texture. For now, we can copy and paste this, right-click it, and convert it to a texture object. This is a very bad idea. I'll show you why after. But for now, it will do. So now we can connect everything as needed. The parallax UVs into the UVs, pixel depth offset into the pixel depth offset, base color shadow multiplier, we'll leave it for after, the specular into specular, world position offset into world position offset, and it's the complexity debug that is used for debug of the material. So we can apply, save, and see the result. Maybe scale it a little bigger. Let's say 5. There you go. As you can see, we have very, very bad ghosting. This is because for some reason the landscape outputs velocity, and we really don't want that to happen. It makes no sense. It's not moving, it's not doing anything. It's only outputting velocity because it's writing in the warp position offset, but it's not moving. So the solution to this is going to project settings, search vertex, and there's this option, output velocities due to vertex deformation. Turn it off. Now you can see it doesn't ghost anymore, but this can create a problem because it's a global setting. But this is why they recently added this. If you search pixel, you have this has pixel animation checkbox. I'm just going to show you what it does. It re-enables velocity even if that is off. So if you have something like a tree that swings with the wind, I suggest just keeping everything off by default and using this checkbox to enable it on the stuff that you need. It's way better than the default behavior that everything has velocity. That's very not ideal. So now I'll be showing you why using the 4K texture is a bad idea. So if you enable stat unit and stat FPS performance, and we increase our samples to a crazy number, you'll see how the performance tanks. This is unacceptable. 24 frames. Why is this happening? Well, first of all, the texture size. It actually samples based on the texture size, and you do want to have as low as a texture size possible before it starts to lose too much detail. My sweet spot, I'll show you now. So what you need to do is copy and paste this texture, then right click, source reduce size, and my sweet spot has been 512 by 512. Click OK. Let's look at the difference already is made. 23 frames. We use the new texture, we apply 42. That's really double the frames. But the most important part of this is we go inside the texture, filter, and you switch this to bilinear. Look at that. 80 frames from 15. That's a huge difference. It scales very well now with a crazy number of samples. So if you use something like 64, it's basically gonna be almost as performant. From what the test I did, it's as performant as just a normal material. So talking about samples, I can show you as low as you can get with this system. So this is 64 samples. This is 32. This is 16. You can see with 16 samples, which is extremely low, it still looks completely fine to a degree. You can see the blue noise dither in effect, especially in these areas with such low samples. Let's go, 32. Was 15 there, was my mistake. Doesn't matter much. Now if we switch back to the normal dither, you can see the comparison in here. You can see how this looks very static and weird, especially at distances like that. We switch back to our blue noise dither. You can see it's way smoother. It like smooths it all out without looking static and weird. This is what it does. So we can go back to our 64 samples now, which is my recommended number, minimum. Something to mention is that I'm currently using ambient occlusion for this. But you could technically, if you want, still multiply the base color by the multiplier, because it gives it a penumbra, which ambient occlusion does in this case. And we can adjust that in the material instance. Like that. It's just something worth mentioning, but for now I won't use it. If you use contact shadows, you're going to encounter a problem. So if you go into our directional light, contact shadows, and go like 0.3 as a value, you're going to see some weird glitches in the shadows, especially as you approach the landscape. The solution to that is to go into your landscape and disable contact shadows. Like that. You'll get rid of those very, very nasty looking glitches. We can talk about optimization now. To talk about that, we can disable the artifacting fixes right now, which are experimental. And the main part we're interested about is the POM optimization, which consists of the optimization radius and hardness and just a normal camera sphere mask based on distance. So we go into the material instance and look what it does. If we bring this closer and increase the hardness to 1, we can see the moment when the texture turns into a parallax occluded texture. Like that. And to visualize this properly, we can drag this complexity debug into the base color. Green means optimized, red means just running POM, really. Here it's less complex because based on angle, there's more iterations. And how are we sure that this actually is running an optimization? Well, we can run more samples and actually see if it makes a difference. We're now at 50. If we bring it closer, 100. If we bring it further, we start losing frames. So that's the way we make sure this actually works. Now we can turn the complexity view off. And add the other material to blend. Remember to do the same for displacement texture. And then go inside and switch this to bilinear. Now we'll do just a basic setup. We can actually copy all of this, paste it, and just change the textures. Landscape layer blend. 2 layers. One is moss and the other rock. You can apply, save, go to landscape mode, paint, save everything. I guess it got buggy. So if it does that, just reload the map. So we click the plus, white blended layer, normal. Just click save. Do the same for the rock. And now we can paint the rock. As you can see, we now have 2 layers running parallax occlusion mapping. The main issue you'll encounter with this is that at very steep angles, very close-up angles, you get some ghosting effects, which is totally normal and really unavoidable at this point. If the height differential is too much, you'll get these ghosting effects. There's possible ways to get rid of these effects. The experimental one I'll show you. This is the best way to show what the experimental changes do. Is that right here. We just connect it again. It just flattens the effect based on the angle you're looking at it. So it's an optimization step too, really, at that point. You can see it in action over here when I do this. You can really see much of an issue here, but as your landscape starts curving, you'll notice a lot of issues with the ghosting effects of that type. So this is my first attempt to solving this issue. So I thought it would be fun to showcase the character working this map in full screen, so you can see the effect and everything put together working. You can see how this feels three-dimensional. But if we bring our camera down, it doesn't really glitch or do anything weird. There we go. So I hope you enjoyed the video. I'm sorry if the microphone quality, the overall video quality is not the greatest. It's my first time doing a voice video and my first time editing really a video of the matter, like this type. Not really experienced with any of this. But if you have any questions or anything, missed anything, and anything you want to ask, just leave it in the comments. I'll 100% reply to it. If you have any tips or anything, just to generally say, will be more than appreciated. I hope you have a great day, evening, whatever. Take care.